The next part of section 2.3, we are talking about the amplitude and period of our trigonometric graphs. First thing we want to talk about what it's meant for a function to be periodic. And if you look at the definition that's on page 40, it says a function is periodic if there is a number p such that f of x plus p is equal to f of x for every x that's in the domain of f. Okay? So that means if we remember that if I'm doing something inside the function, this is shifting my graph left or right if I'm doing it in a regular function. But in a periodic function, with this fact holding true, that means your graph is repeating every p units. Okay? And what we need to do is we need to identify how many units it is to repeat. So before we go into the two examples that are printed in your notes, let's go to the basic sine and cosine function. Okay? The period is how long it takes to repeat. And we said sine starts at 0 going up. So if I want to go from where it starts at 0 going up, I want to go this until it gets to starting at 0 going up again. This distance right here is one period. Okay? And in the case of sine, that one period is the distance of 2 pi. Okay? I didn't have to start at 0 going up. I could have gone from the 1 point going down and I still would have had a length of 2 pi for the period. And you're going to see that on the cosine function. Starts at 1 going down to the next place that it's 1 going down. Okay, the distance between 0 and 2 pi is 2 pi. So my period here is 2 pi. So what we want to do is we want to ask ourselves how long, what is the period of these two graphs? These are repeating. It's the exact same picture, repeating over and over again, just horizontally translated down the graph. Okay? And I want to know what the period is. So in order to find the period, let's find a starting point, okay, here, and an ending point of my picture. And I just want to know the distance in between these two. So I have 3.5 minus 1.5 is 2. So the period of this graph is 2. And that was example 2.26 on page 40. I'm going to do the same thing for the next graph. I just picked one that has a starting point and an ending point. Find the y values, 1.5 minus 0.5, and I get 1.0. Okay? So, or in this case, we'll just call it 1. The period of this graph would be 1. So you should be able, if I give you graphs, be able to determine what the period is directly from using the x-coordinates and y-coordinates of the graph. Okay? So the basic fundamental period of sine and cosine are both 2 pi. Well, we saw when we were doing graphs of other functions that if I multiply by the number inside the function, I'm going to end up with some stretching or shrinking horizontally of my graph. And that the same thing is true with the sine and cosine function. Okay? So let's talk about what the graph of sine of 2 theta would look like. Okay? We're going to talk about the graph of the sine of 2 theta. Okay, I am not going to repeat the table that is in your book. Okay, it's on page 41. I use the same fundamental points of pi fourths, pi halves, 3 pi fourths, 3 pi halves that I did for the previous video. okay? And you notice that in the table, what I'm doing is if I multiply each of these by 2, so I'm going to do one of them. Let's do a couple of them. Y equals sine of 2 times 0, okay? And the points I'm getting here are these on the unit circle. Those are the ones I'm putting in. Okay, so 2 times 0 is 0. The sine of 0 is 0. Okay, if I put sine of 2 times pi fourths, that's equal to the sine of pi halves. Okay, and that is square root of 2 over 2. Actually, sine of pi halves is 1. And then if you follow along in plotting the points that are in the table, okay, the graph is already plotted for you on page 41. This is the graph that you get. So, oops, that is not the graph you get because I didn't follow my own thing. I said pi halves. I'm so used to doing it divided by 4. Pi halves, I'm at 1, then back to 0, negative 1, 0, positive 1, 0. Here we go. That's the positive side. And then the negative side, at pi halves, I am, yep, I really messed that one up.